Chapter 7, Section 5 is on geometric sequences. So this is going to look a lot like something we did earlier, okay, which was arithmetic sequences, only the difference is now geometric sequences, which means it has a constant ratio. So this time we're either going to be multiplying or dividing each term to get to the second one. So geometric means multiply or divide, okay, before we were doing addition or subtraction. So this should look very familiar. Okay, the new thing is how to find the ratio. In order to find the ratio, you're going to take the second term and divide it by the first term, and that will find out what you're multiplying by each time. Again, we have two different formulas. The explicit formula was just a straightforward one, which meant you could just plug in the number of the term you're looking for and figure it out. Okay, G sub 1 still stands for your first term. R stands for the ratio which you're multiplying by, and then the n is the number of the term that you're looking for. So if we looked at example A, it says find the first four terms in this sequence. Well, I should notice that this -1 is actually my first term, and 3 is my ratio, which means that's what I'm multiplying everything by. So -1 times 3 is -3. -3 times 3 is -9. -9 times 3 is -27. Okay, so take your first term, multiply it by the ratio, and keep multiplying by that same ratio, and you will get your first four terms. So hopefully pretty straightforward. Example B wants you to actually give it the explicit formula. So this time it's giving you the sequence and you want to write the formula. So what you need to find out are two things. You need to find out your first term, okay, which is pretty easy to find, which is 6, and then you need to find your ratio. So to find your ratio, we said you take your second term, which would be -1.2, and divide it by your first term, which would be 6. If you divide those out, our ratio is going to be -0.2. So I have my first term and my ratio, so now I just plug it into my formula. So my formula says G sub n equals G sub 1, which is our first term, which is 6, and then in parentheses our ratio, which we found, which was a -0.2, and then to the power of n minus 1. Okay, so just plug in those two variables and we're all set. Okay, the second kind of formula is the recursive formula. Recursive formula was a little trickier because there was a little bit more information. The first part still tells me the first term, so G sub 1 is still my first term, and then the second line is my actual formula. So now it tells me my ratio, and then if you remember that whole thing with the sub n minus 1 part, this thing right here meant the previous term. So it means take your previous term and multiply it by the ratio. So it means the exact same thing as the explicit formula, it's just written in a different notation. So if I'm given this formula and I'm asked to find the first four terms, well, it's pretty easy. I already know that my first term here is 3. And then down here, this is my ratio. Okay, so it says take 5 times my previous term. So 3 times 5 is 15. And then take 5 times my previous term, which is 15, which will give me 75. 75 times 5 is 375. Okay, so there's my sequence. Okay, so first things you have to find are my first term, which is this first piece of information, and then in my second line I'm given my ratio, so I just multiply everything by 5. Example D then is working ourselves backwards, so it gives me the sequence and it wants me to write the recursive formula. Again, you're looking for two things. You're looking for your first term, which is pretty easy to find, and then you're looking for your ratio, which is your second term, 5.5 divided by your first term, 0.5, which tells me my ratio here is 11. Okay, so now I'm just going to plug in the information I have into the formula. So it says my first term is 0.5. And then it says G sub n equals R, which is my ratio, 11 times my previous term, G sub n minus 1. And then after all of these, we need n is greater than or equal to 2. So you put those on all of your recursive formulas, and that just means use that second line, use that formula for the second term and everything thereafter. You don't need to use it for the first term because they give you the first term. So use it for the second term and everything after. Okay, so those are some basic ones. Let's look at some more challenging ones. Example E says, find the first four terms in the geometric sequence that has a constant ratio of 1/4 with a first term of 12. Okay, well then I know my first term is 12, and if I have a constant ratio of 1/4, that just means multiply it by 1/4. So 12 times 1/4 is 3, 3 times 1/4 is 3/4, 3/4 times 1/4 is 3/16. Okay, So pretty easy again, first term and then multiplying it out. Example F says consider the sequence 3, 6, 9, 12, 15. Is this geometric? Why or why not? Okay, well, 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 3 is 15, or 12, 12 plus 3 is 15. Is that geometric? No. Okay, because you are not multiplying by the same value. Because you have no constant ratio would maybe be another way to say it. You have a constant difference, okay, which makes it arithmetic, but geometric means you're multiplying by the same amount, so that's a no. So just make sure that you're careful there. Geometric means multiply. Okay, example G, if a geometric sequence has a first term of 144, the second term of 72, write the explicit and recursive formulas. Okay, so for both things, I need the first term, which they give me, and then I need my ratio. So my ratio was found by doing the second term divided by the first term. Okay, make sure that you are kind of remembering to do that maybe backwards in your brain. Second divided by the first, not the other way around. That's a common mistake. Your constant ratio then here is 0.5. Okay, so you're multiplying by a half each time. So the explicit formula was G sub n equals the first term, so 144, times my ratio, 0.5, to the power of n minus 1. So that's nice and straightforward. The recursive one was one with the brackets where there's two lines. So the first line is still my first term, 144. And then the second line was like my formula. And then it said G sub n equals my ratio, 0.5, times my previous term, which was G sub n minus 1. And then all of these needed n greater than or equal to 2. Okay, that's just part of the formula. It's like a label, and it has to be there. Okay, so let's look at an application problem. A ball is dropped from a height of 5 meters and bounces to 90% of its previous height. Write the explicit formula. Okay, so explicit formula means I need my first term. So I would say that this 5 meters, where it starts, would be my first term. And then my ratio would be my 90%. So I'm going to turn that to 0.9 and then to the power of n minus 1. So then how high is it after the 10th bounce? Okay, well, that means I want my exponent to be 10 here. So that would give me 1.74 meters. Okay, so it's geometric sequences. Hopefully it made sense to you because we've seen things like this before. If it didn't, though, write down some questions that you still have, and we'll talk about them in class tomorrow.